Hello and welcome to Fouraye Education. Today I will be teaching financial mathematics and I'll be continuing on with some new concepts, again relating to expectations or to the use of expectations. I'll be introducing the concept of martingales today. However, before that, I want to touch on stochastic processes. Stochastic processes are again a very vital concept in financial mathematics. Now, what are stochastic processes? Let's say t is a set of times. A stochastic process denoted with fancy brackets xt with a given condition. This can also be written this way in some sources. You can also have an inequality condition here, similar to this one, or they can sometimes denote L2 space or similar things. So anyways, a stochastic process, this is a collection of random variables defined on our space. So let's say t is 0 to, 3, right? So we'll have x0, x1, x2, and x3. And this can go all the way up to anything, basically. Stochastic process is basically a collection of random variables. So now that we know stochastic processes, we'll move on to martingales, the main concept. What are martingales? Now, let's say we have a process. xt is stochastic process. Shortly, we'll say process with a set of times t. This is a martingale with respect to the filtration ft if, first of all, xt is integrable for all t in big T. Next, xt is adapted to the filtration ft. Next, x of s is equal to the conditional expectation of f of t conditioned to f of s. This is the key component of a martingale. This little equality over here. This is very important. So, and also, it has to have a constant expectation. So, let's go ahead and let's go ahead and see how this concept works, right? So again, imagine a tree per se. S1, S2, S2 tails, heads, S3 heads, S3 heads, tails, heads, S3 tails. So how do we know whether this is a martingale or not a martingale? Say we have P and Q, right? If S1 is equal to the conditional expectation of S2 subject to the filtration S1, then it's a martingale. Similarly to this, subject to filtration at 2. We could say S0 too, but well, whatever. So T yeah. So let's see how we look at this. So S1 is the conditional expectation of S2 subject to F1. So if you look at it, this is just basically P S2H plus Q S2T over 2. But since at time 1 we don't exactly have any information, this is quite useful. So look at time 3. So say H. We have the information that the first row is H. So now we want to look at the conditional expectation of S3 subject to the filtration of 2 with the information H. Now see, we have this, we have HH here, we have HT here, we have TH, and over here we have H. So what we do is P times S3HH plus Q times S3HT and divide by 2. Now if we just took the expectation normally, we had to do this, right? So now we can just do this. And this has to be equal to S2H. If this condition is satisfied, it's a martingale. Sometimes it's not, sometimes it is. If it's bigger than, it's a super martingale. If it's smaller than, it's a sub martingale. Anyways, that's it for the concept of martingales. Thank you for listening. Be sure to like and subscribe.